All right, let's cover it. Chapter 7. It's about spoofing. Okay, kind of a cool one. And this is a brand new assignment I made. Thought of it today. Made it today. So the odds of there being some slight bugs in it are not only good. There might be a slight issue. I haven't found any issues yet. No one's done it yet. Okay. All right, spoofing says a sophisticated way to authenticate one machine to another by using forged packets. Basically, it's a way to make it someone pretend you're someone else. That's what it really is. Okay? It really goes into trust and authentication. You don't know what trust is? How about on a network? Do you know what trust is? Where one machine trusts another, like a domain model. This machine's trusted on the domain, that kind of stuff. But it's not always the best thing. It's kind of funny. When I worked at Tinker, we were developing a new system, and we wanted our system on a separate domain. So we wanted to set up a one-way trust so that we could actually use it on the Tinker domain. So the Tinker domain would have access to our system, but it would not be reciprocal. In other words, we couldn't get out, but they could get in. That way we could log into our work machines and do it. And my boss was like, oh, no trust whatsoever allowed on any military domain. Well, there's a two-way transitive trust automatically built into a domain model of only a machine. So I tried to show it to him, and he goes, no, that's not available. I'm like, dude, right here. Two-way trust between every machine on Tinker. Well, we enabled it. He never knew, so we were good. So again, it was we only did one way, so I could log into my work machine and get into the test machine, just not the other way around. But kind of cool. Authentication is another issue. Did I tell you the issue with Terry Byers and taking tests while we're doing this whole proctoring thing? Okay. First of all, this lady came at the beginning of the semester, told us all about cheating, which was good. I knew there was a lot about it, but we really need to do something about it because it really devalues your education, believe it or not. Well, Terry Byers, about 2 weeks before spring break, gave a quiz in class. In class, a class he's been lecturing to the entire semester. He said, hey, before you can take the quiz, I need to see your ID. No big deal, because the testing center, you need your ID now. I don't know if you know that. 2 of the students said, I left it in my car, let me run out and get it. They have never been back to class yet. So, he reported the students, because you can go online, I think it's $400 right now, to pay someone to sit in a row state class and guarantee you a B or better. Oh. So it happened this semester, 2 students in Terry's class. I'm like, seriously? So yeah, he reported. I don't know what happened after that point. But, have I seen all y'all's IDs? Probably not, but we probably need to start that next semester. At least, once in a while to know you're really who you are, which is actually a good thing. It really is a good thing. All right. Okay. So pretty much on the network, you're communicating to somebody. Who you're actually communicating? Internally, between this machine and my office machine, do you know how I communicate? Do you know how I decide who to talk to? Anybody know? Actually goes by MAC address. Because the IP address can change. If you have, for a while there was SBC Yahoo DSL. Remember that was a few years ago? That would literally change by the minute. You'll be using it, and they would literally change your IP address while you're using the system. Cox, they usually at least give you a 1-day duration lease, and it could change at that point. Right, and my Cox hasn't changed in years. But SBC Yahoo would literally change while you're using it. They had a smaller address space, and as machines were being used, they would give you that. It was weird. It was weird. But pretty much internally, you talk via MAC addresses.
Okay. Can you port forward based off a MAC address instead of an IP address?
No, you cannot. But okay, like in my house, internally, I port forward based on IP. A certain port goes to a specific IP. Depending on your system, some of them you can do it to specific MAC. Like I have a camera recording system that does work by MAC. Internally, rather than point to the IP of the camera, I point to the MAC of the camera. So it's pretty. But you can also always use reservations to make sure you get the specific address you want. But it's not always that easy. Okay. So the authentication is less critical when there is more trust. It says a computer that's authenticated by an IP, host, and MAC address. Obviously, this is a good thing. Okay. All right, but there are flaws in TCP. It was never made for security. Okay. You ever watch one of the videos about the very beginning of ARPANET? Security was the least smallest thing on the brain. They didn't care. It's kind of one of those things, ooh, I got it to work. And they just never thought about security until what? Later. They didn't think about security until later. This thing drives me crazy. Okay. Okay, it has a basic flaw that allows spoofing. It says trust and authentication have an inverse relationship. Okay. And bottom one here, most fields in the header can be changed. Okay. We're going to look at some of the fields, but quite a few of them can actually be changed. Require no authentication whatsoever. We're going to talk about those. Okay. Says simply requires forging a single header. Because you know how TCP has the three-way handshake? Once we get the communication going, I mean, we're golden. We can talk all day long. If I can break into yours or create another one, that always makes it easier. So it says requires sustained dialogue. Once the machines are talking, they continue to talk. Okay. William, see the email I sent you? Okay. It says it could pay up to $95,000. I don't know. It might be interesting to you. So, by the way, there's a job offering for it's a 1-year commitment for. They want a security engineer. They want a senior level, but they don't have the money for it, so they're going to pay a junior level. But depending on your experience, it could pay more. So if you're interested, let me know. I can get you more information on it. Okay. So it talks about here the first one. IP is unreliable. Okay, IP is like the addressing on an envelope. Just because I address the envelope correctly, does that mean it's going to get where it's supposed to go? In my neighborhood, I get a lot of UPS packages. And for the longest time, I was always getting this guy. See, I live at 8412, and there's an 8212. I was always getting his packages, so I was always walking over to his house. I get tired of it. I mean, it was literally once or twice a week I would get a package from him at my house, which sucks. Finally, I called UPS one day and said, hey, I need you to come and do this. And I'm like, but isn't he like 3 doors up? I'm like, yeah. Can you just walk it up there? He says, no, I've been doing it for a year. You need to come and pick up this package. So they drove out there. They've never done it since then. So they were just being lazy. Oh, we're giving Ken one as well. We'll just drop him here because Ken's going to walk it up there for us. So, but IP is unreliable. It's really just addressing. That's all it is. Okay. TCP is the one that's actually connection oriented. It actually makes sure they get where it's supposed to go. But there's issues with that as well. Okay. It uses indexing, which we can talk about sequence numbers and stuff like that here in a second. All right, here's our header. We got a version, we got a length, type of service, the total length, the flags. Some of these you looked at on some of the assignments. Time to live, addressing, destination, all this stuff. It really doesn't check it. It just assumes that it's correct. Okay, a package's address, someone changes it, it can still go through. Okay, so to spoof a trusted machine. So identify the target pair of trusted machines. In other words, I'm going to get between you two. Okay. Calm you down, in other words, get you so busy you can no longer respond with a SYN flood or something. So take one of them out of the system. Okay. Then forge something, pretending I'm you. Okay. Then connect to him, and then we just continue to go. And if I stop flooding you at that point, when you try to get back in the conversation, your machine. It won't work because the sequence numbers are no longer correct. Okay? It says you can use Analyzer, which I did to actually capture the packet for this assignment. Did anyone download the packet yet? Was it okay? Did it download okay? No one's downloaded it? Oh, seriously? No one's done it yet? But I put a packet capture up there. I'm not always sure if Canvas lets you download it correctly. But it is up there. To kill someone, you can do a SYN flood attack. You can ping them a whole bunch. I mean, a massive amount. Some people think a single ping is going to kill somebody. You need to do a lot. Computers nowadays can handle quite a bit. Okay? Wireshark, you're in capture packets. You guys have seen that before. Okay, you see the packets coming through. I think they add some pictures like this just to, we have pictures in our slides. I really don't do a hell of a lot of anything. But nothing new here. You all seen how you can filter out based on different things. You can filter out based on IP address. You can filter out based on port. You can based on anything. So pretty simple stuff there. So which is kind of nice. And I did take my pack and do some filtering to make sure that what you need is actually there. So I kind of did a little bit of error checking on it. Okay. Now, so it says forging the address of the machine could be done with the same utility. There's so many. We're just going to talk. There's lots of different utilities out there now that you can just forge packets very easily. Okay. Problem is guessing it. Okay. Sequence numbers, but they're not random. We're going to see here in a second. Okay. So if it's not a random number, then obviously it's easier to guess because it's not random. It would be nice if it was totally random, but it's not. Okay. They start at 1 when it's turned on, and increment in fixed values. Okay. Here's an example. I still couldn't figure out what they were trying to show here. Oh, they're showing the sequence number. Okay, right there on the right. Okay, here's how they increment. Every 1 second, they increment by 128,000. Okay, one connection is 64,000. Then the different type of packets, what they increment by. So, with enough time and energy, you could figure out how long the machine's been on, what its approximate number is, and you could guess the sequence number. So, it can be done. Okay. All right, it says once you have that trusted machine asleep, so I got his machine sleeping over here, send a SYN packet to Andrew over there, okay? Connect on 23 or 25 to see where his numbers are, to figure out how fast they're advancing, because you need to know that, okay? Then we need to come some sort of round trip time, in other words, how long does it take to get there, how many hops are between you and there, okay? Then you're pretty much in, but you got to make sure when you're done you release the other machine as well, which I don't think they cover, but yeah, you just need to release it. That's about all I can tell you on that, because it'll kind of give away our project if I tell you too much about it. Okay, but here's a picture. It's basically you anesthetize one, get in between them, guess the number, and you're good. Now there are a lot of vulnerabilities out there. When I took care of these gyms, their DVR recording system had a sequence number guessing attack vulnerability, or it gave too much information. And they had to quarterly hire a external firm to do an external scan on them. And every time they would fail them because of the sequence number guessing attack. Every time. And I had to contact them, and we basically had to say, hey, it's on their DVR recording system, totally separate network from their credit card payment system. So what, you break into the DVR, you can see a video. You can't get into anything. There's no customer records. There's no nothing. So we had to justify that every time. Basically, it was every quarter for every gym location. Because for everyone with that same version of DVR, because they weren't updated. Even the manufacturer of the DVR said, nah, we've come out with a new version of the hardware. So you're not going to fix the old version. No, because we come out with a new version. I'm like, yeah, but how many people don't want to spend the money to buy the new? I have no system to record 30 channels at one time, built-in hard drive. Those are expensive. So they basically said, all right. And so we had to justify it every time. And I'll tell you, those scanning companies, they take their job seriously. They just don't, approve you without a lot of justification. So we had to send them information on the DVR and how, if you get in, here's what you're going to get. But, it is doable. Okay. All right. Here is a picture of a ping command. Ooh. Y'all seen ping before? It's pretty handy. Okay. All right. The costs. Okay. It says the costs of the victim of successful spoofing, it says, are tied to the amount of information that we can copy. So you can connect to me, what are you able to get off of mine? So if you're getting in between their communication, what were they communicating at that point? What am I going to get out of it? What am I going to be able to do with it? Okay. Okay. All right. And a lot of times they leave it back to us, they can get later. Okay. You have an economic loss, could be money. Okay. Valuable data is lost or duplicated or whatever. It could be strategic. Now you know the plans of somebody. Okay, whatever they're doing there. Okay. Or it could be data loss. You just lost some data, like the VCR recording at Rose State. You no longer proctor your test. Still can't believe it. Okay. All right. Now they say in here, unsecured documents is really where a lot of data comes from. People sending where they're not supposed to go, that kind of stuff. Okay. Email them, put them on flash drives and stuff. Okay. Types of smoothing. Here's where your assignment comes in. I picked one of these, and I did it between some machines. And you need to figure out which one I did. And I want you to tell me how you know I did that one. You did blind spoofing because blah, 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 blah. And here's what blind spoofing is. That's what your assignment is, which I'll show you more about in a second. But okay. So we're going to talk about blind, active, IP, ARP, web spoofing, and DNS spoofing. talk about each one. Blind says, any kind of spoofing where only one-sided relationship under attack is in view. I don't know what these two were doing. I just know what he's doing. So it makes it a lot harder because I can't really determine what's happening on the other side. It's not aware of the network conditions. I don't know what's going on. I don't know what he's doing at all. Okay, makes it tougher. This picture's, it says, hi Phil, this is Bradley. I'm calling to let you know that we've decided to go with George's bid on the contract. So he's telling Phil we're going with somebody else. Okay. But at the same time, Bradley could be calling. I'm trying to call Phil to let him know that he decided to go with it, but his phone's dead, so he's been anesthetized. So Bradley's been kicked offline so that George could tell Phil what's going on. So, but yeah, as I said, the picture's not the best. I don't know how you can make a much better one. So, okay. Active, it says now you can see both parties, observe the responses from both of them. Okay. And it says various exploits, sniffing data, corrupting data. There's all kinds of different stuff you can do with it. Okay. IP says consistent attacker accessing the target's disguise as a trusted third party. So I made my IP address. I mean, anyone ever configure a Cisco router in here? One of the very basic things you do in a router is you tell it, first of all, do not allow internal traffic inbound. In other words, if internal we're a 1010 network, or we'll say we're 66210 network. That's what mine was at home. So internal, I'm 66210 something. So should 66210 come in? No, it's already in. So you block yourself from coming in because you're already in. You block 127, which is the loopback address. You block the 1010s because those are private addresses. They shouldn't be coming in. You block the 192s, the 172s. So you block all these private addresses and yourself from coming in. Makes sense. And what do you block going out? You should be the only one going out. I mean, 66210 should be the only one going out. Okay. No one else should. 192 shouldn't be going out because they're not in. So I would, the outbound is the other way around. It's only allow 66210 out, block everything else. So it's pretty basic stuff there. But still, if you were to spoof a packet and get it on the network, see, the problem is when you create false packets, you can just inject them onto a network. You don't have to get approval from anyone. You can literally just inject it on a network, and if you get the sequence number right and the addressing right, it could go wherever. So could be an issue. So that's why HTTPS is so important, because it prevents that. Okay. So it can be done either way. So IP spoofing is a big deal. ART spoofing is modifying the address resolution protocol table for hacking. Now let me show you. I don't know if you guys have ever seen this. You should have. Okay. Let me make this a little larger here. Let's go font. Everybody see that? Somewhat? Okay. I'm going to ping BS-131-01 and 3. I'm just going to ping 2 addresses. Okay. I'm going to ping Google. Okay, just a couple different addresses. I pinged 3 different addresses. 2 internal, 1 external. Does anyone know why Google's not working? Because we block inbound and outbound pings.
Oh.
It hits our firewall, because remember, Google's not inside. So my ping went to the firewall, and the firewall said no. Okay. So that's why that one did. Now internally, between here and my office, we don't block stuff. Okay. Now, if I do ARP-A, ARP-A, it gives me my routing table. Okay. What this is IP address to MAC address, is what it is. Okay. Now let's find what was my machine. Oh, there's a bunch. Okay, 131.01 up there at the top was 1060.203.2. So I should be able to get on this list. 1060. Oh, that's right. We got 2 darn subnets. Hold on. Is the other one 50? Okay, good. Let's go with this one instead. We'll do 03. We got 2 different subnets in this building. We got 1060 and 1050. Up at the router, they're joined together, but I'm still having to go through the router. But we'll use this one here. 1050.200.30. See that right there? Okay. So if I get on 1050.200.30 right here, it gives me the MAC address. B8 AC, the one right, almost at the top. Let's see, let's get it at the top. Okay, the one right at the very top, that's the MAC address of the machine. The IP address can change all day long, but the MAC address will never change. The problem with ARP is ARP does what it's told. I always make an example and I tell people, it's like children. You wish they would do what they're told. ARP does what it's told, okay? So if I was to tell ARP, hey, that IP address belongs to someone else, or that MAC address is different for that IP address, they'll believe you. Say, oh, cool, thanks for letting me know. So, kind of scary tool, okay? Kind of scary. It says, the ARP table stores the IP addresses and the MAC address. It stores them between 2 and 10 minutes, depending on usage. Things that are used quite frequently are stored for 10 minutes. Things that are used infrequently are only stored for 2. Sounds kind of weird, but that's the way it is. It says the router searches the ARP table for destination first. So when I want to talk to my machine in there, first thing I do is send out an ARP request. Hey, does anybody know where this machine is? And that machine responded, hey, that's me, and here's my MAC address. Now from that point on, see, the first request was a broadcast, sending out network-wide. Then after that, we made unicast requests between me and that machine. So we continued to talk directly between us. Okay. So it says the router searches for the MAC address. ARP spoofing attacks involves detecting broadcast, faking the IP address. So if I was to listen into the network for all the ARP requests out there, because they're broadcasts, anytime anybody wants to talk to anybody else in this network, first thing it does is a broadcast. I can say, he wants to talk to him. Immediately send out a forged packet saying, hey, I'm his address, not him. Because once Andrew gets the MAC address, he never wants to talk to the IP again anyway. So it's kind of scary the way it works, but it does. There are ways to make it better where it requires authentication, but by default, it does not require any authentication. Okay. Here's an example. I don't know what the hell they're doing with it. Oh, it's just an example arcade. Okay. Okay. Web spoofing says hacker spoofs an IP address to a website. It's kind of, I think of it like a proxy. Anyone ever used a proxy before? A good example of a proxy, maybe your place blocks Facebook. On the internet, type Facebook proxy. There's thousands of them out there. What happens is you're going through them to get to Facebook. So it's very hard. I mean, if you know anything at all, you can pretty much do anything. Okay, unless all the proxies are blocked and everything else, which is a tough job. Now, Tinker does a decent job, but they block everything. So it's kind of crazy. Okay? So it says, then the hacker can transfer information. When I ran my DNS at home, when I ran my ISP, I always had to make sure I turn off zone transfers. I didn't want people to grab my addressing or modify my addressing, because if they did, that would really cause issues. Okay? It would really cause big issues. What would happen if I was an ISP, say I'm Cox, I'm running their DNS server. I get the zone, DNS zone, in other words, all the addressing information for Google. So I can actually get it quite easily. Okay, I can get off the internet just using DNS tools. And then store that on my local machine, so now I become what's called authoritative for Google. So anybody on Cox's network, first thing to do is ask me, because I'm on Cox's DNS. So anybody on Cox's network, first thing to do is ask me, and I say, oh, I'm Google. Can you imagine how much of an issue that would cause? Then I could have it go anywhere. So I'll tell you, DNS is such an issue. When we bought out an ISP, we bought out one in Tulsa, Galstar Systems. The guy really messed with us bad. He changed secret words. He changed all kinds of stuff, caused issues. And the problem is we use AT&T WorldNet or WorldLink at the time for our nationwide dial-up service. This is in 1990. And the problem was, to edit their DNS, they had to have it 48 hours prior so they could approve it before they implemented any changes on their side. And they only did it on Tuesdays and Thursdays. So it sucked. So we got them the request in time, and they put it in place for Tuesday. Then we realized something was screwed up. One of the machines was wrong. We had to fix it. So we submitted the request for an update. Next update's Thursday. It's not 48 hours out, so it didn't happen until the next Tuesday. So it kind of really sucked, but it was really bad. But addressing through DNS and everything could be a big issue. Okay, and people could very easily fake certificates. That's the big issue Microsoft had a few years back. Someone got in and made some fake Microsoft certificates. Now there are fixes for that out there, something called CRLs, Certificate Revocation Lists, which you'll learn about in Security Commerce. Those are used to flag bad certificates. But until I think it's like X509 version 3, which is the current version of certificates out there, that wasn't available. So, yeah. I was always wondering, because when I ran my ISP, I used to sell certificates. And they gave me a free one. It was valid for 10 years. That's a heck of a time for a certificate, isn't it? Can you imagine if it got exploited and I couldn't get it onto a certificate revocation list or something? It's just weird the way all that works. But that's spoofing, another big deal. DNS is what I was telling you about there. DNS spoofing, people could edit DNS, become primary for it. And a lot of places now don't even host their own DNS anymore. Okay? I have Cox at home. So you think I use Cox for DNS? No, I don't. I use Google. So if you don't use Google, I recommend using them because they're 8.8.8.8. Super easy to remember. It's all 8s. Or 8.8.4.4. The reason is, if you ever have, if you have Cox and your internet ever goes down, the odds are it's not Google or Microsoft or somebody you're trying to connect. There's probably something in Cox's end, their DNS servers or something. So if Cox's DNS servers go down, you get nothing. So what I do in my router is obviously I'm getting an address from Cox, but then I mainly configure the DNS and I put in Google. Put in Google, all the 8s, then I put in 8.8.4.4, and then I put Cox as the tertiary or the third entry. Never gone down since. So if you need help doing that someday, I can help you with your own router. It's pretty simple, but yeah, that's what we use here even. In our labs upstairs, not Rose State, but in our labs upstairs, I use all Google stuff. Because they're pretty darn reliable. I don't know if you guys realize that at this point, but okay. So, but with DNS, someone can alter the IP address, direct you to a different location, can cause all kinds of issues. Okay? Here's the picture. The picture kind of sucks. Okay? All these pictures in this chat. I was going through these pictures like, wow. What they're doing is they're telling you a different address for PayPal. You're connecting to the wrong thing. We're actually going to do an example of that here in a second because I'm going to go to a slide which I'm going to show you. Okay? Some of the tools, AppSend, EtherCap, and ARP spoof you can use to do some of this stuff. Okay? AppSend is a kind of a cool utility. It's a Unix-based utility that you can make fake packets. You can make all kinds of stuff. You can do send floods. You can do another one they don't mention here is HPing3. It's even available for Windows. Be careful doing that because we actually done a couple of projects with HPing3, and it can send out 40,000 packets a second. So be careful. You could literally take a network. I tried to do a project a couple of years ago using a Linksys router. Project went live. Student number 1 killed the router. I'm like, what the heck? Rebooted the router. He hit it again, killed the router. It's because Linksys router is not made for 40,000 packets per second. You can't handle it. And that was one student. So it's pretty bad. But AppSend allows you to do all kinds of spoofing attacks. And thinking these are only 3 of the tools. There's tons of them out there. Okay, there it is. You just run AppSend, and it runs. EtherCap, the same kind of thing, and you can do more. I don't know if this one's still out there. It might be, but I haven't played with this one in a very long time, actually. But you can do ARP poisoning, where you can go in and basically change the ARP tables, which is kind of nice. Okay, you can drop packets. You can do all kinds of stuff. There's the help for it. I don't know why they show you the help, but you can see the help for it. Okay, works on Linux-based systems. Yes.
It's older because didn't you have us do the HPing3 in one of our projects earlier, and I was able to ping some network that normally can't ping regular, but if you use HPing.
Right, HPing3 can allow you sometimes to ping networks you can't normally ping. Yeah. And you can. What's cool with HPing, you can even say you're a different address. You can say, oh no, I'm not this IP address, or I'm not this MAC address, and you can actually make it. You can have it generate random sources. Okay, imagine me, hitting Thomas with 40,000 packets, but the sources are all randomly generated. So he's going to be responding to 40,000 different addresses that aren't even me, and then working with all those. See, stuff. I know for a while there, I don't know if this is still true, but for a while there, the way Cox was managing spam was, if a mail comes to you, no big deal, it's yours. But if a mail doesn't come, say, a message comes to, I think my Cox email is KDewey6 or something, I don't know, some stupid address. I don't ever use it. But what if they someone sent a message to K2E7? Right? It would hit the Cox network, and if it doesn't exist, Cox would reject it. You understand? It would send it back. But if it was sent from an invalid source, remember these spammers don't care to get it back. So if they send it to K2E7, Cox rejects it. Then Cox would send it back to the source. The source doesn't exist because it's random. So then it rejects back to Cox again. So Cox is end up messaging or handling that email 3 times. So it's tough. So what Cox does, they do best guess. And they used to. I don't know if they still do. They would pick the email address closest. So, oh, we don't have a K2E7, we have a K2E6. They forward it to me. It sucks, but it's really a good way to get rid of a lot of spam on their end. And most spam filters now, I mean, I use Google now, and I don't know, I didn't get one piece of spam. That's all I get. So it seems to be working better on that end. Okay? ARP spoof, part of the DNS stiff suite. You can tell an IP address and a MAC address. You can change it. Okay? You can change the MAC. You know how I showed you that list? This IP has this MAC. I can change it to say, no, this IP is this MAC instead. So very scary stuff. Okay. All right. Yeah. Okay. I showed you the demo on that. Okay. So prevent. I thought there was another slide in there. I guess not. Okay. Okay. I think it's coming up here in a second. Okay. So to defend against it, just use trust relationship to reply on IP addresses only. So if they work on IP addresses only, MAC addresses aren't that big of an issue because they can always be updated. Okay. On Windows systems, you can't remove it. Do read-only access on the host file. That's what I wanted to show you. Let me show you something here. Okay. If you go to C, Windows System 32, drivers, etc. If you go to this folder, you got some files. You got a host file, an LM host file. Well, let's open up this host file right here. Okay. I'm going to open this up with TextPad. Okay. What this is how the internet used to work. This is kind of like the manual DNS. It's an IP to a name. That's all it is. Okay. I'm going to go down here now. I want to get an IP address for Google. Okay. So 74.125, I'm going to put it in here. So I'm going to go 74.125.192.147. I'm going to say that is www.yahoo.com. I'm going to copy. So I used to copy it on my Mac. I do it on Windows. It's different. Excuse me up. Okay. So what I'm doing is I got Google's address right here, and I'm editing my host file. There's something called name resolution in Windows. How it handles. The first thing Windows does is checks this file. This file was around since day one of the internet. Still there. So what it does is it checks this file first. Well, actually, the first thing it does is checks its cache. Has it been there before? If it's been there before, it goes back where it's been before. But if it's not been there in a while, in other words, the cache has been cleared, it checks this file. So now I'm telling it, whenever you try to go to Yahoo, you've got to go to Google. Let's see what it does. Watch it not work. Okay. Yahoo.com. Everybody see that? I got Google. Isn't that nice? So years ago, we had some secretaries. This is many secretaries ago that did nothing but MySpace. Remember when MySpace was popular? That's all they would do at work. It's like, you want some work done? They're like, in a minute, in a minute. So I actually got permission from IT Services and the Dean. I edited the host file of the 2 secretaries we had in there. And all the websites they went to, I redirected them to the Rose State website. And they never complained. What are they going to do? Call? Hey, I'm trying to surf MySpace at work and it's not working. Had a guy somewhat works for me, kind of like where Cameron works now, Josh Posey. Really nice guy, but he would do a lot of Reddit and Fail Blog, I guess, and those kind of websites. So I did the same thing. I put in his host file and I made a fake website with basically one page that said, Josh, get to work. So whenever he went to any of those sites, they sent him to, Josh, get to work. And he couldn't remember how to fix it, so It's a very, I need to do that for that stupid thing Cameron does in there. That's a good idea. But you can very easily do that. So at your house, just edit that file, and wherever your kids are going, put an IP address someplace you know that you're okay with. You see how simple it was to do. And the bad thing is there's viruses out there that do this. What they do is they wait until you go to your bank or something. Then they edit the host file to add your bank's name with a different IP address. So it's very scary stuff.
So basically your host file should have everything commented. You really shouldn't have anything that works on that.
Unless you have something like Spybot, Search and Destroy, and some of the antivirus programs will put stuff in there.
Oh,
Like
okay.
Spybot is always updated, and when it finds out about bad websites, it puts them in here, directs them to null or something. So if you try to type in www.badip, whatever the website is, it doesn't work.
Okay.
So
But it's still a good thing to check that.
yes, it is. It's a very good thing. And Scott actually told his students that if they could edit mine, they would get extra credit. So Cameron kept trying. But what he would do is he would have to log me off to do it. Because my machine, I never log off my machine, it's always locked. So whenever I come in the next morning, if it's a login prompt, it's either Rostate did an update overnight or Cameron was screwing with it. First thing I do, check here. And I said, sorry Cameron, you fell again. He has never got it successful yet. It's like, how do you know to check that? I'm like, because it says you're logged on last. I mean, it's not a biggie here.
He needs to use Colin.
Yes, exactly. So, but pretty simple to do. So, make this file read-only. I should probably leave that in there. That'd be funny. Nah, I better not. But I've gone in and I've turned off user switching to prevent it from screwing. Because what sucks is I have a lot of stuff that I leave up, and I don't want to log in every day. That's way too much work. Okay, so what was that? Okay, so that file, kind of important. Even though it's left over from the dark ages of the internet, it does check it. After cache, it's the next thing that it checks. So you can see how you could have an issue in there. And as a normal user, you wouldn't have a clue how to fix that. I keep typing in Yahoo and it keeps going to Google. I don't know. And I guarantee you call Yahoo, they're not going to have a clue. First they won't answer anyway. But okay, so Linux systems, TCP wrappers allow that. You can put a firewall in there with rules on that. There's lots of different stuff you could do. Okay, encrypt your internet. But for most people, that's not a viable solution. Having IPsec internal is not normally good. Okay. Says to avoid defend against ARP poisoning, use message to deny changes without proper authorization with the ARPS table. I don't know exactly how to do that even, because I don't know anyone who does it. There's got to be a way to do it. I just don't know how to do it, because that ARP sniff can do it, and the Cane can do it. There's a lot of tools out there that can change your ARP table very simply. So there's got to be a way to require authorization. I just don't know how to do that. I need to look it up one of these days. You can also have static ARP tables. I don't know if you noticed that mine, the very bottom part was all static. Those are ones that are hard-coded by somewhere on the domain. They don't want those to change. You can also log changes to it. If it's a file, you can have auditing turned on for that file for access or edit it or failures, whatever. Okay. All right, that's the end of this chapter. Let me stop this recording. Okay, then I'm going to make one more.